right, happy Tuesday. Today is February 23rd, and you can kind of see what we're going to do for the week. Today, there's nothing for you to submit, but it's super important that you understand what I'm talking about today so that it can lead into your practice tomorrow, where you're going to be on your own. So, we're going to talk about Punnett squares, and I'm going to start by going to the next slide here. On this slide, we're going to see three different scenarios today, and it is going to be kind of progressively more difficult. So we'll start with the easy one, where they actually give you the crosses. Sometimes they're called crosses. You're crossing this with that. You're crossing, these are called hybrids because they have a dominant and they have a recessive allele. One, now, of course, this could be, yeah, this could be across from humans. So maybe dad's allele is here and mom's allele is here. So this person, whoever this is, got one from mom and one from dad. And then this is crossed with whoever this other person's alleles. There's one from mom and one from dad, or vice versa. So there's one dominant and one recessive. And this is for straight and curly hair. So from this, you should probably understand that straight is dominant over curly because they use the S. Okay, it doesn't outright say that. This is a practice, probably one that you're going to actually do. So let me show you how to set this up. If you don't mind, I'm going to turn on my pen, and hopefully it'll write halfway decent. Now, I will caution you on some letters of the alphabet. R's are really good because there's a capital and lowercase r. You can really tell the difference in the two. Like I'll show you. Big R and little r. They look much different. But S, if you don't make them way different, it's hard to tell which is dominant and which is recessive. So, straight hair, I believe this is dominant over curly hair. Okay, so you got one allele for straight and one allele for curly. So what's going to show up? The straight has to show up because it's dominant over the recessive. The only way you'll see the curly hair is if there's two curly hairs. So what we're going to do is work this out. So we're going to take one of these and put it up here. We'll do this two more times after this. So you'll really kind of get to know how to do this. Same thing over here. Now both of them are the same, right? And I'm trying to make them very different so that you can kind of see it. Dominant, dominant. These are two recessive. So what you do is this box is whatever's above. Not now, of course, this box is not what's above here. It's what's above all the way up top here. We're dealing with the genotype from one parent and then the other parent. So what you're going to do is you're going to put these two S's right here. Now, I'm making them super big so you won't get confused. Now, for this box here, it's whatever's above and to the left, all the way to the left. You're dealing with this information and this information. These have nothing to do with what goes in here. So you're going to take this little s and this big S. Always put the dominant first, then if there's a recessive, put it second. Again, you should have, remember this is a dominant, this is recessive. So we're going to put whatever's above, that's a dominant. And whatever's to the left here is a recessive one, we're going to put that. And again, it's this goes here, and this goes here. So there's two little S's. What should this tell you? These are called genotypes. And the phenotypes, this is a phenotype. Straight's a phenotype and curly's a phenotype. Okay? So, what you're going to do is each one of these is 25%. Okay? So you're going to add them up. Now, you have to understand that S stands for straight if it's capitalized. If it's lowercase, it's curly. But this wins out. So what is this going to look like? It's going to be straight here because there's two of them. They're both dominant. This one has a dominant and a recessive. Which is going to win out? The straight here. This line is just straight here. This one has a dominant and this is recessive, so the straight has to win out. And the only time that the recessive alleles will show up, if that's all you have, is those recessive. So curly hair would be like this. So just kind of a something to look at there. So 25, 25, and 25. 75% will be straight and 25 will be curly. Okay, on the next one here, you have another scenario here. We've got one more after this one, and then we'll be done. So let's say that this is talking about seals, seals that have whiskers. What you need to know is that this kind of sets it up for this scenario here, for this word problem. It says, let's say that in seals, the gene for the length of whiskers has just two alleles. Okay, it has a dominant allele and it has a recessive allele. The dominant would be a capital W, and then the lowercase recessive would be a lowercase letter. Now, which means it's going to be short whiskers. Okay, so with that, we can come down here and figure this out. So what we have to look at, first of all, it tells us on this one, again, it's going to kind of at least tell us what's dominant and what's recessive. On the next example, it won't say what's dominant and what's recessive. So here we go. So what it says here is, what is the probability? And you have to understand that this Punnett square shows you the probability of what could take place. Like the probability of you flipping a coin, it's going to be 50-50, right? Well, if you had a four-sided object instead of a coin, there's a 25% chance for each one of the sides. So it says here that you're going to, what's the probability of producing offspring that have short whiskers from a cross of two long whiskered seals? One is homozygous, and you have to understand what homozygous means. Homozygous means, homo means same, okay? It means same. And then heterozygous means different. And I'm not going to write that out because it takes so long for it to write out. All right, so it's homozygous. Now, there's two different types of homozygous. There's homozygous dominant and homozygous recessive. So this is homozygous dominant. What letter are we using? They already told us. We're using W's. Okay, I'm going to put this homozygous dominant right here. Homozygous dominant would be capital, because it's dominant, right? And I'm going to make them super big. Wow, that looked weird. And then heterozygous would be, heterozygous means different. There's only one way you can have something that's different. If you're talking about letters like L, that's a capital L, and then this is a lowercase l. That would in fact be heterozygous. Homozygous would be two capitals or two lowercase. But here it tells you it's dominant. So if it's homozygous dominant, you're going to have capital W, capital W. The only way to write heterozygous, you have to write one capital and then one lowercase. I'm going to make it super small so that you can see the difference. So you're going to fill in here, goes above and to the left, and it's going to be two capital W's. I'm going to have to overlap to get them in there. Okay? And then this one, of course, these two go here. And then this one, the lower and the upper. So always put the upper first. And then I'm just going to put a little bitty one right here. And you can hardly see that. And then again, it's this one and this one. So you've got a capital W and a lowercase w. Now, what you should be able to see out of this, let me put this like that. What you should be able to see out of this It has a capital in each one. That means it's dominant. So what's going to show up is the capital, which is long whiskers. Now you could have used L for long and then the lowercase for short. That would have worked just as well. But they already set it up with the W, so that's probably the best thing to do. So 100% of them. I don't know why. And that's supposed to be. There we go. And then none of them are going to be short whiskers because there's no little w, little w. So there you go with that one. Now we're going to move on to the next one. And I'm going to have to take my pen off here for a minute. And let's go on to the next slide. Now, Mendel did a lot of different types of research on pea plants, whether he's talking about the configuration of where the flowers are, or whether they're tall and short pea plants, or color of the flowers, or the color of the peas, or whether the peas are wrinkled or round. Now we're going to use some different, this is the one we're going to look at today for this next scenario. Not the color, but this is, and we're going to go with different wording here. We're going to go with smooth versus, now it's not really wrinkled, but that's what they call it, wrinkled. I would call it pinched. I've heard of it as that because it looks like they're pinched. You can't tell how many peas are on this one as you can this one. I know how many peas there are. Three, there's 6 of them. I don't know how many's in there. Okay. But anyway, what we're going to go with, just so you can kind of understand, this is smooth and this is wrinkled. What are we talking about? We're talking about the pods. These are peas. These are pods. Okay. All right. So this next and last one is put off to the very end because it's the most difficult one. So let me read it to you first. It says a heterozygous smooth pea pod plant is crossed with a wrinkled pea pod plant. There are 2 alleles for pea pods, smooth and wrinkled. Predict the offspring from this cross. Okay, so in order for this to take place, you're looking for what is dominant, what's recessive. It doesn't flat out tell you, so you have to make an inference and you have to look at this part right here. This part right here tells me, okay, how does it tell me this? Well, first of all, the pea pod is smooth. Is smooth dominant or recessive? And here's the other one, right? You're crossing a smooth heterozygous with a wrinkle. Okay? Well, let's just look at any scenario. And I'm going to use a different letter. And let me just set up this scenario. So I'm going to use X's. Okay? Whatever reason, this is super slow. Right? So these are the only combinations you can actually have for any scenario. Super slow for whatever reason. Okay, so here's the setup here. Oh, perfect. All right, so you have 2 dominant, 1 dominant, 1 recessive, and 2 recessive. Okay. Now, like I said, X's, I just made that. You can use any letter for this, and it's still going to be the same thing. Okay, so this is homozygous dominant. This is heterozygous. This is homozygous recessive. So homo means same. Hetero means different. Okay, like a heterogeneous group is a kind of a mix of people. So this is what we're talking about here. heterozygous smooth. So if it is smooth and it's showing up and it has a dominant and recessive, well, what is the dominant trait? It has to be smooth because you have one dominant, one recessive. Okay? Now, so let's look at this. So if I erase this, then we'll go back to, we know now that it's smooth is dominant. So we're going to go with, this is heterozygous. Man, it's so slow. All right, there we go. Capital lowercase. It has, heterozygous means you have one dominant, one recessive. Which one's going to win? The dominant's going to win. What do we know? It says right here that it's a smooth pea pod. Okay, so smooth, if it's smooth, it has to have one dominant and one recessive, or two dominant. And it says it's heterozygous, so this is heterozygous. If there's another way you can write it, and that would be, but they did not say it is homozygous dominant, or it would look like this. This is smooth, this is wrinkled, smooth, smooth. What's going to show up in the smooth wrinkled? Only the smooth, because it's dominant. Okay, now so we know this is the setup right here for this one. So now we have to figure out the setup for this wrinkled here. Well, this doesn't show up. The only way this is showing up, the wrinkled will show up, is you have to have another wrinkled. You can't have a dominant. So you've got to have the two little s's in order for it to be wrinkled. So that's supposed to be an S. Let's fill it out. So we need this one and we need this one. Doesn't matter where. Let's put this one on the side. So heterozygous. And this is going to be homozygous recessive, which makes it wrinkled. Real small. Okay, so how do we do this? This one and this one go in here. Capital, lowercase. Sorry it takes me so long. Capital, lowercase. And then this is little, so we've got lowercase, lowercase. Sorry, those letters don't look like S's. All right, so now what we need to look at is these are both little, so 50% are going to be wrinkled, and 50% of them are going to be smooth. Okay? So smooth. So it says, what is the genotype for the smooth? So here's the genotype for the smooth. So big S. This is kind of to start you out, right? The genotype for the smooth was this. Why? Because it's heterozygous. One big, one little. What was the genotype for the wrinkle pea pod? Wrinkle, there's only one way. Little s, little s. Okay? And then the last thing is, I'm fixing to run out of time, so I need to hurry. The last thing is the percentages. It's 50 here. And 50 here. Okay, and there you go. So 50% of the time you're going to have wrinkled from this combination here, these two that are crossed, and 50% of the time you're going to have 50% you're going to have smooth and 50% wrinkled. Okay, Hopefully that helps out for tomorrow. Okay? Have a great day, guys.